This is section 6.1. We're talking about the equation of a line in slope y-intercept form, y equals mx plus b. So there's nothing necessarily brand new today. The concepts you guys have already learned. We've talked about the equation of a line. We've talked about slope. We've talked about y-intercept. We've talked about what those variables are, so m and b. So we're going to just skip through the investigate. We're going to go straight to the examples. It should be pretty straightforward. So in chapter 2, well, let's do that right away. So go to example 1. It says identify the slope and the y-intercept of each linear relation. Use these values to write the equation of the line. So we should be able to do this already, I would think. Let's do A. So what is the slope? Or sorry, let's do the easy one first. What is the y-intercept of the graph there, A? Yeah, Tyler?
-5.
Yeah, -5. Why? How do we know that? Well, it crosses the y-axis at -5 right here. Okay? And what does that represent, that -5 in the equation y equals mx plus b? Alvin? Good, b. So for b, we would write -5 then at the end. The slope now, a little harder, but not too much. Tim, how would we get the slope here?
We go one down and one thing.
Sorry?
So we pick a point.
Yeah.
So I picked 6 and -1,
Okay.
and then I go to another point, which would be 5 and -2. So we do y2 minus y2.
No, so it doesn't quite cross -2. You got to be careful. So when you pick 2 points, Tim, it's really important. I'll zoom in a little bit here. Maybe you can see it a bit better. You have to really make sure that the line crosses through that point. Okay? So 6 -1 is a good point, but 5 -2, you can see here that the line misses. Okay? So Adam, which point would you choose?
3, -3.
3, -3. Good, yeah, so it crosses right through there. Okay, so we have these 2 points then. And now how do you get the slope? Yeah?
y2 minus y1 over x2 minus x1.
Excellent. So we could do that another easy way, nice when we're working with graphs and the units are all the same as they are here. We can actually just do rise over run by looking at it, right? We can see that it rises 2 when it runs 3. So slope would be 2 over 3. And it's positive because this is going up. Alright, so if we go down here to A, we can see slope ends up being 2 over 3. Okay, so we could have done it also using the points. And in this case, they actually used negative, what did they use? 6, -1, and 0, -5. So they use this point down here. Let me zoom out again. They actually use this point right on the axis, okay? Which is another great point because it's very clear where it crosses through. Does everyone understand that it's your choice between which points you choose on the line? Do you guys get that? And understanding that any 2 points will give you the same slope. The only reason why it's important, the point that we choose, is because it's easily visible. You guys get that? Okay, that's important, right? Because it's not just, any point. It's these 2 points here that we can see are clearly going through that intersection point. All right, B. Sal, what's the y-intercept and what's the slope?
So the y-intercept is going to be 3.
Good.
And the slope is 10 down and 5.
So which points are you using?
Just all of them. Should I just use 2 points?
No, don't use all of them because it's not even clear where this ends, right? It's not clear where this ends. So you got to choose 2 points, Sal, that are very clearly defined. So what points are you going to use?
I'll use 3, like the y-intercept, and
Yeah.
2, -1 on the x.
Okay, good.
So 4,
Yeah.
so it'd be 4 over 2 or 2 over 1.
Yeah, that's right. 4 over 2. So you're saying it's lowering 4. So negative 4, 1, 2, 3, 4. And it's running 1, 2. Yeah, good. Excellent. So again, you could have done it by just getting those points and then using the formula y2 minus y1 over x2 minus x1. Okay? So our equation of that line then would be y equals mx plus b, where m is negative 2 and b is 3. So we end up with this equation here. Y equals negative 2x plus 3. Any questions there? All right, C, Sebastian. It's a tricky one. What's the slope?
0.
Good. Slope is 0. So in that case, if the slope is 0, your m value is 0. So y equals 0, x. And then what's your y-intercept?
4.
Plus 4. So your equation becomes y equals 4. Because that goes away, right? Does that make sense? And now if you look at the graph, y equals 4, that also makes sense, right? Y is always 4. Okay. Justin, behind Sebastian, D.
Undefined.
Sorry?
The slope is undefined.
Right, so the slope is undefined.
X plus 0. Oh no.
Oh, sorry, x plus b. In this case, what's b?
2.
0? No, it's also not there, right? There's no y-intercept either, right?
Undefined.
Yeah, so we don't have any value for y. Undefined x plus undefined. So the only thing we have a value for is what? Alvin?
X.
X. So what would be the formula for this equation?
X equals 2.
Right. This is dx equals 2. Does that make sense? We cannot define y as anything here. We don't have any value that we can define y. Okay, let's see what the book writes about this. The slope is undefined. There is no y-intercept. A vertical line cannot be expressed in the form y equals mx plus b. Look at the graph. What do you notice about its x-intercept? The equation for this line is x equals 2. This means that for any point on the line, the x-coordinate is always 2, no matter what the y-coordinate is. All right? X-intercept. Very important definition. It's the coordinate of the point where a line crosses the x-axis. All right? So we all know what the x-axis is. Wherever your line crosses that axis, that's your x-intercept. It's intercepting that line. Any questions? All right, let's move on. Example 2. Okay, the slope of the y-intercept are given. The slope and the y-intercept are given. In each case, write the equation of the line and graph the line. This is really easy. They're giving us both pieces of information. So, Luca, at the back, what's the equation of this line?
Y equals 2 over 4 x plus, plus 2 negative.
Plus 2 negative. Okay, rather than saying plus 2 negative, you might just write,
Plus negative
same thing, you might just write negative 2, right? Instead of writing this, you're going to write this here. You guys see that? I don't want to see plus negative 2. It's just negative 2. Adam.
Do you want us to leave the m as a fraction or put it as a decimal?
If it's a clean fraction like this, it's fine. I always prefer fractions because they're exact. All right? But you could put 0.075 if you wanted. If you really have an allergic to fractions. All right, next thing we need to do is graph this. So where's a good starting point whenever we're graphing an equation of a line? Where might you want to start, Henry?
Y-intercept.
Yeah, y-intercept. Why?
Because that's just
Because it's given, right? It's already given, yeah. And you know it's at the value where x is 0, your y-intercept, you can start on that point. And you need a starting point to do the slope, right? So you need that y-intercept. Once you have that starting point here, you're going to go ahead and do the slope pattern. So in this case, you're rising 3 and you're running 4. So from this point, I would go 1, 2, 3, 1, 2, 3, 4. In the book here, they chose to run 4 first. Doesn't matter. I prefer thinking of it as rising 3 and then running 4. You would have ended up with the same point. Okay, next point you do the same thing, rise 3, run 4. Okay, you get 3 points, you can draw a straight line. Any questions? All right, B, Joseph, the equation for this line.
It's y equals negative 3x. Just y.
That's right, yeah. Y equals negative 3x, perfect. How would you slope this? What would the y-intercept look like on the graph? Where would it be?
Start at 0.
Yeah, 0, 0,
Yeah.
right? 0, 0. So here's your 0, 0. Negative 3x, so that means you're going down 3. Remember, when your slope is a whole number, it's actually that number over 1, right? It's still a fraction. You can still think of it that way. You're running 1. So here you're going down 3 over 1. Down 3 over 1. Any questions? All right. C here, the other Joseph.
Y equals negative 1 over 2 plus, plus 5.
1 over 2.
Negative plus 5.
You said that again. Say it again.
X.
Yes, good, x. Don't forget the x. All right, so again, your y-intercept is positive 5, so you start there. You're going to go down 1 and run 2. Down 1, run 2. Last one here, your slope is 0. Yeah, Adam?
Y equals 6.
Y equals 6, and it's going to be a, what kind of line? No.
0. No slope.
Yeah, what kind of line does that look like?
Horizontal.
Yeah, horizontal line. Just at y equals 6. Which is right here. Any other questions with example 2? Very straightforward, very simple. Example 3, interpret a linear relation. Identify the slope and the vertical intercept of each linear relation. Explain what they mean. Write an equation to describe the relationship. All right, so, yeah, sorry. Matthew, behind cell. What's the y-intercept on this one?
5.
Okay, and what's the slope?
It would be 5 and over 0. No, sorry, 5 over 10. And then no, since it's going down, it'd be negative 5 over 10.
Good. Negative 5 over 10. So you use this point and this point. You use the two endpoints. Good. And you said negative 5 because it's going down and it's running 10. So it's actually negative a half, right? 5 over 10 is a half, right? So what's your equation of this line then, Matthew?
Negative 5 subtract 0. And then 10 subtract 0.
No, what's the equation of the line?
Oh, y equals mx.
Right, and what is that then?
B is 5.
Yeah? So what's the equation of the line? You got it. You got all the info. Sorry?
M is the slope.
Yeah? It's okay. He's got it. Everyone yells at him, makes it harder. Matthew, look here. Okay, can you see the paper up here? Right? Here's your y-intercept. Here's your slope, right? And there's your equation of line. All this information you already gave me. So now create the equation of the line for this particular graph.
So y equals negative half
Yeah?
plus
Missing one piece.
negative y negative half x.
Thank you. Good. All right. Okay, so there's the equation of the line. And it says, explain what they mean. So what does it mean, the y-intercept? Matthew.
How far he is from the wall?
Yeah, she. I think Tracy's a girl. Could be a guy. And not the wall, but I think it's, I guess it's the wall or her house or his house. And then what's the slope mean? This is a good one. We should know this. Everyone's hand should go up. Distance time. What's the slope, guys? Robert.
Of which? B? A.
Wow. You're passed out, eh, Robert?
I thought we were on B.
Tracy's wall. We're on 3. For which?
Okay, Robert, you see that graph here? It's on the screen where my finger is?
Yeah.
Okay. We determined that 5 is the distance away from her house or his house, okay? What does the slope represent? It's negative 1/2. What does it represent?
Oh, her walking towards her house?
Not really. You're right, she's walking towards her house, but what's the slope represent on a distance time graph?
Her speed or?
Yes, good. Her speed, okay? So more specifically, she's moving at a 1/2 meter per second. 1 meter for every 2 seconds. Is that fast or slow?
Slow.
Yeah, it's slow. It's actually got like crawling speed, right? 1 meter is 3 feet. It's basically a step. So she's taking 1 step every 2 seconds. So it's like a really slow walk. All right. Or she has really, really short legs. Yeah. All right. Okay, B, Robert, you're awake?
Yeah, I'm good.
All right, let's do this. What's the y-intercept?
6.
Good. What does it mean, the y-intercept?
That's where it's a starting point
Of what?
of the tomato, yeah, it's the starting point of the tomato plant. That's when it starts growing. The height.
How is it 6 already at the starting? How does that work? You don't ever buy tomato plants at the store?
Yeah.
Does she buy seeds? What?
I don't know.
After planting.
Oh, okay. I'm confused.
Steven.
It's probably tomato plant's probably bought at 6 centimeters before it starts growing.
Excellent. So before we start this experiment, Nona went to the grocery store. She bought a tomato plant. It was already 6 centimeters tall. Then we started measuring further its growth. Okay. What is the slope of this graph, Tim?
It's wet. So it's too
What's the slope?
Isn't it 2/1?
Yes. It's 2 over 1, so the slope is 2, right? What does the slope represent, AJ?
How fast the plant is growing every week.
Yes, good. So the plant is more specifically growing, in this case, 2 centimeters per week. Does that make sense? All right, finally, Christian at the back, what's the equation for this line?
Y equals 2x plus 6.
Excellent. Yeah.
It's 4.
Yes, sir, it's the slope is.
The slope's 4?
Yes, it goes up by 2 each time.
Oh, okay, yeah. Yeah, very tricky. The y-axis there is going up at twice the rate as the x-axis. It was very, it actually would look more like that then. Yeah. Good, it's 4. But you guys get the idea, right? All right, key concepts. The equation of a line can be written in slope y-intercept form. Y equals mx plus b, where m is the slope, b is the y-intercept. A horizontal line is written in the form y equals b, where b is the y-intercept. The slope of the horizontal line is 0. And vertical is written in the form of x equals a, where a is the x-intercept. The slope of the vertical line is undefined. Any questions? All right, that's it.